Artificial intelligence looks weightless on a screen. But behind every answer sits a physical machine, and behind those machines sits a financing boom so large that the Bank of England is now watching it as a potential financial stability risk. JP Morgan estimates that more than $2 trillion of funding may be needed for the AI chips used to train and run models over the next 5 years. That is not the whole AI build-out. It is the chips alone. The demand is real. Companies are buying processors, memory, networking, cooling systems and entire buildings at a pace with few historical comparisons. The risk is not that nothing is being built. The risk is how all of it is being paid for. This creates a simple but uncomfortable mismatch. The debt can last for a decade or more. The machines it finances may become commercially outdated far sooner. Long-lived promises are being written against short-lived hardware. To understand why that matters, separate the building from what sits inside it. Concrete shells, substations, and cooling plant can operate for years. Chips, memory systems and rack designs live on a much faster technology clock. TSMC, the world's leading producer of advanced AI chips, says customer demand remains structurally strong across multiple years. It is expanding its Arizona investment to $265 billion. This is not a timid industry. At the same time, the chips themselves are changing. OpenAI and Broadcom have unveiled an accelerator designed specifically for large language model inference, promising better performance per watt and a multi-generation platform. Custom silicon is moving quickly. Britain is making the same strategic bet at national scale. Its new AI hardware plan commits £1.1 billion, including a national supercomputer and hundreds of millions for next-generation chips. Governments are now participating in the hardware race. Until recently, the largest technology companies could fund much of their expansion from their own cash flows. According to the Bank of England, that changed around 2025, when required investment began exceeding internal financing capacity. In the first half of 2026, AI-related companies accelerated their use of public bonds, bank lending, private credit, leveraged finance and structured products. The hardware boom began spreading its funding needs across the wider financial system. The 5 largest AI-focused technology companies represented only a small share of outstanding US investment-grade debt at the end of 2025. But by early May, they accounted for more than 15% of new issuance that year. Private credit is also moving in. The OECD estimated its share of financing for AI investment rose from 9% in 2024 to 34% in 2025. More capital can accelerate construction, but it can also make risk harder to trace. Most long-duration debt has so far financed the building and facilities rather than the processors inside. That distinction matters. A building can be refinanced against leases and property. A chip is a rapidly changing piece of specialized equipment. Credit investors often prefer maturities longer than 10 years. That works naturally for airports, utilities, and buildings. It is less comfortable when the financed asset may be overtaken by a more efficient generation within a few product cycles. Chips do not simply wear out. They lose economic value when newer hardware performs more work for less power, fits different cooling systems, carries more memory, or supports software that older platforms cannot run efficiently. There is genuine uncertainty here. Shortages can keep older processors valuable. Not every workload needs the frontier chip. Inference, research, and smaller models can give previous generations a second life. Depreciation is not a fixed countdown. But the opposite force is powerful. Better performance per watt can change the economics of an entire facility. If a new accelerator delivers much more useful work from the same power connection, the old rack is competing against electricity itself. That is why a frontier data center can become outdated even when its walls are new. If floor loading, rack density, cooling loops or electrical distribution cannot support the latest hardware, the building's useful economic life can shorten. When economic life shortens, 2 things can weaken together: the value of the asset securing the loan, and the cash flow expected to service it. That is the connection between faster chips and financial stability. The contracts underneath the financing decide who absorbs that risk. Long leases, strong guarantees, and credit-worthy tenants can protect lenders. Weak contracts, optimistic occupancy assumptions, or rapid tenant turnover can transfer more of the problem into the debt. Some investment now sits in special-purpose vehicles, securitized data center structures, and other off-balance sheet arrangements. These can bring in more capital. They can also make it harder to see where leverage and losses ultimately reside. The Bank of England also points to self-reinforcing capital loops. Technology companies invest in AI businesses that then buy those same companies' cloud or hardware. Revenue, investment, and demand can begin validating one another. A loop is not automatically fraudulent or unsustainable. Strategic investment can secure supply and accelerate innovation. The concern is correlation. When several balance sheets depend on the same spending cycle, one disappointment can hit many valuations at once. The most important question is not whether debt exists. Productive infrastructure has always used debt. The question is whether repayment schedules, asset lives, and realistic revenue assumptions are aligned, or whether optimism is filling the gaps. Everything ultimately depends on revenue. AI must become useful enough, widely adopted enough, and profitable enough to justify the infrastructure already being ordered. The technology can succeed while individual projects still fail to earn their forecast returns. The build-out can also be delayed before revenue arrives. Grid connections, specialist construction labor, cooling equipment, and water access can all constrain capacity. Debt clocks keep running even when a site is waiting for power. The supply chain is concentrated as well. Advanced fabrication, memory, packaging, and lithography depend on a small number of highly specialized companies and regions. A disruption can delay many projects at the same time. This concentration helps explain why the bull case remains strong. Scarce advanced capacity has pricing power. TSMC's record investment and multi-year demand signals show that customers still want more chips than the current system can comfortably provide. So this is not a prediction that the AI boom is about to collapse. Immediate debt stocks remain modest relative to the wider financial system, and the Bank of England says current risks have so far been contained. The direction, however, is changing quickly. The likely winners are not simply the companies that spend the most. They are the ones that can upgrade hardware without rebuilding the facility, secure power early, shift workloads across generations, and match financing to realistic asset lives. Power access may be more valuable than the building itself. A site with a firm grid connection can host successive generations of hardware. A beautiful shell without enough electricity may become an expensive waiting room. Customer contracts matter just as much. A facility backed by durable demand, strong tenants, and clear upgrade obligations is different from a speculative site built on the assumption that someone will eventually need it. For governments, the lesson is similar. Supporting domestic chips and compute can build strategic capacity, but public money should also reward energy efficiency, interoperability, and useful life, not just the headline size of a new machine. The hidden bottleneck may therefore be neither algorithms nor chips. It may be finance that understands how quickly technology changes. Cheap capital can build capacity. Patient, well-structured capital determines whether that capacity survives the next generation. AI may still deliver enormous productivity gains. The investment may prove justified. But when $2 trillion funding needs meet assets with uncertain life cycles, optimism is no longer enough. The contracts, collateral, and upgrade paths have to work. The AI boom is building more than models. It is building a new credit market around machines that can age faster than the debt behind them. The next signal to watch is not only what the chips can do, but who is still paying when they cannot.